Hello and welcome to the sixth lesson in the second part of statistics in Year 11 Standard Maths. Today we are looking at different ways of comparing distributions, so comparing sets of data. And first we're going to talk about the different ways you can compare data. Then we are going to examine one of the ways you can display a comparison of data. So in the past, the General HSC usually sort of gave you a distribution in the form of a parallel box and whisker plot, or perhaps some numbers or a stem and leaf diagram, those kind of things. And there would be a 2-mark question that would say, compare these two distributions. In general, they were kind of looking for you to do two things. First, they were looking at you to compare the measures of location. So the measures of location are the mean, the median, and the mode. Then they were looking for you to compare something to do with the sort of measures of spread, so the range, interquartile range, the standard deviation that we'll come back to later. So first I want to just discuss the advantages and the disadvantages of the different measures of location. Then we'll look at the measures of spread, and then finally one of the ways you can demonstrate these things. So the mean, let's do that one first. What are the good things about the mean? Well, it is very easy to calculate. It's probably one of the first averages you learn in school. All you learn is you add up all the numbers and divide by how many they are. That's pretty simple. Most people remember that quite easily and understand what you're talking about when you say average. Another good thing is that it depends on all the scores. So when you've got a data set, every piece of data gives some information towards working out the median. So that's a nice good thing as well. What's one of the disadvantages? Well, outliers affect it in a big way. So that is like a drawback, I guess, of the fact that it depends on every score. The outliers do affect it more so than the other measures of location. So that's a bad thing about it. And it's the same for the mean and the median, but I'll say it now. We can't use the mean for categorical data. So if I asked everyone in the class their favourite colour, collected all the results, I wouldn't be able to find the mean colour that was the favourite of the class. So that's a bad thing about it. As I said, that's the same for the median. So I won't mention that one again, but it does affect. The median, not necessarily easy to calculate because of that process where you have to find the middle, but actually it is easy to understand. So most people, when you tell them, oh, the middle score is this, and you're either above the middle or below the middle, they can work out what that means quite quickly. So that's helpful. The median, it does depend on all scores because you have to know how many scores there are and find the middle of it. But if there are 1 or 2 scores right at the edge, those outliers, they don't actually affect it as much as they do the mean. So the outliers don't affect as much. So that is another good advantage of the median. What are one of the disadvantages? Well, the data does need to be sorted. So that is a bit more time consuming. So that isn't as helpful as the mean. The mean, it doesn't matter what order they're in, you just add them up and then divide by how many there are. Mode, what's the big advantage? Well, it is very easy to find. It is just the most popular one. Whichever number comes up the most often, that's really easy to find. Not affected by outliers, because as with the median, the outliers, it's usually just 1 or 2 of them. They don't occur a lot of times. So outliers aren't going to be the most common pieces of data, so that's a big advantage. They don't affect them as much. The last one is that it is used for categorical data, so it's kind of the opposite to the median and the mean. That's a good advantage. What's a disadvantage of this one? Just separate these off quickly. The main disadvantage of the mode is that it might not be central. So, like I said, these measures of location are trying to give you an idea of where is most of the data located around about. You could quite easily have a distribution where most of the data was sort of caught up in this little bit, but then you get a weird jagged spike comes up here, like that. And this is the mode here, marking with a dot, but actually there's very little data in this sort of area. Most of the data is in this big block here. And so perhaps you've measured it badly, but this is a rather extreme example where the mode doesn't look good. Okay, so the next part is the advantages and different ways of comparing data when it comes to the measures of spread. So the three options we've covered are the range, the interquartile range, and the standard deviation. Range, what are the advantages? Well, it is very easy to calculate. You just find the highest score and you take away the lowest score. Whatever the answer to that is the range. What are the disadvantages? Well, outliers have a big effect. So if there's one very large or very small piece of data, or even one large and one small piece of data, that has a really big effect on the range. And it's more than the others. So that is a drawback. One or two pieces of data can make it look like there's a really huge range, even if most of the time it was between a much smaller area. Okay, so that's the range. What about the interquartile range? Well, the advantage of the interquartile range is that it's easy for small data sets. So if you think back, most of the questions in the book, they're probably not more than 20 pieces of data in a set, and that's what you're working out. If you had a list of 100, that would be really tricky. We wouldn't tend to use it for anything too large, although computer programs, of course, do make it easier to calculate these times. It is easy to understand. It's the idea that it's where the middle 50% of data is. Most people can understand that pretty quick. And it, unlike the range, it's not affected by outliers because we're looking at that middle 50%. If there are one or two extreme values at the end, well, they don't really affect the calculation of the interquartile range. That's good, that's helpful. The disadvantage, it's kind of similar to the median, really. The disadvantage is that it needs to be sorted. If you're doing it by hand, that's a pain. Quite easy to make mistakes with large data sets. Of course, most math these days, it would be done with a computer program or a calculator, so is that as relevant? Possibly not, but it is still a disadvantage. The standard deviation then is our final thing. What's good about that? Well, it does depend on every score. So the idea that every score actually has what we call some sort of weight to the calculation. It is involved in the calculation, and so that helps make it relevant to all pieces of data. That's pretty good. It is affected by outliers, not as much as the range, but it is more affected than it by the interquartile range. So I'm just going to summarize that as it's only a little bit affected by outliers. So better than the range, not quite as good as the interquartile range in terms of how much outliers have an effect. What are the disadvantages? Well, kind of it's the opposite to the things above, really. So it is hard to understand. Most people outside of mathematics students will not come across standard deviation. It won't be explained because as a concept, it is hard to get across to other people. So it doesn't help that way. And it is definitely very hard to calculate. In this course, we just use a calculator. You could use some spreadsheet programs to work it out for you, but there's no way we'd ask you to do it by hand. Funny enough, when I went to school, I did have to calculate it by hand, and I had to use the formulas that we knew. It's pretty time consuming, pretty boring. It's nice to see where it comes from actually. If you ever get a few minutes, perhaps have a look at it so you can kind of get an idea of what's going on. But yeah, it's too time consuming for most people. Okay, so that is actually it. We're not going to look at ways you can compare these in terms of drawing the parallel box and whisker plots. That's actually going to come next time, the next video. So there is now an exercise 10E that you'll need to work through in class. As always, make sure you've written these notes down, bring any questions for your teacher. They'll probably let you know which questions are the best ones to do, but just ask for help. Okay, so thanks, and I will present another one of these soon.